we have seen what is the generating function for PD of n. Now, the next obvious question would be, what is it for PO of n, right? Let us see. We'll first address x to the 6, so coefficient of x to the 6 in the expansion of these polynomials. We'll consider these polynomials 1 plus x square so on, 1 plus x square x to the 4 so on, and the other polynomials, right? We'll ask for the coefficient of x to the 6. So, as we have seen earlier, it is a 1-1 correspondence between the partitions and the coefficient of x to the 6 in these polynomials. So, I'm going to use the yardstick of partitions here. Consider this partition of 6, all ones, right? Now, how do we obtain the x to the 6 term of this partition? We have all ones, right? So, it is very easy to observe that we should always go to the first house, one's house, that is, right? We have all ones. How many ones do we have? We have 6 ones, and hence what is the term in the polynomial? Yes, it is x to the 6. So, x to the 6 corresponds to the partition 1 plus 1 plus 1 plus 1 plus 1 plus 1, right? This x to the 6 is the term corresponding to this partition. Now, because it is in the ones house, right, we have all ones here, and therefore we went to the ones house. Now, what is it for 3 plus 3? We have 2 3's here, right? So, we go to 3's house and choose x to the 6. Why x to the 6? Because we have 2 3's. What if I had 3 only, right? For 3 is equal to 3, let's say. Then I would choose x to the 3, right? From 3's house. So all ones had x to the 6 from the 1's house, and 2 3's have x to the 6 from 3's house. Now, what would it be for 1 plus 5? So here we have 1 1 and hence it is x in, and 1 5 and hence it is x to the 5. So 1 is from 1's house and 5 is from 5's house, right? So 1 plus 5 will correspond to x into x to the 5, which is x to the 6. I had 1 1 and hence I chose x. I had 1 5 and hence I chose x to the 5. Did you observe in this process that we have always been asking for all odd partitions, right? I have not chosen a partition which has an even summand. Now, the last one would be, okay, we are done with everything. So now, look at the boxed polynomials here. What does it correspond to? You must be jumping and tell me that these polynomials will correspond to those of the odd partitions. Those partitions which have only odd summands, right? We are concerned only about these boxed polynomials. Why not the others? Let me ask you this question. Because, very easy to observe, only if I have a summand as 2 in my partition will I go to this house, right? Only if I have a 4 will I go to this house. Only if I have a 6 will I go to this house, right? Since I do not have a 6, a 4 or a 2. Why? Because I am concerned only about odd summands. And hence I am not going to choose these houses, right? I am only concerned about these houses, right? So, now let us see what is in general the generating function for PO of x. PO of x is the odd partitions of x. It is going to be 1 plus x square plus x cubed so on into 1 plus x cubed plus x to the 6 plus so on into 1 plus x to the 5 plus x to the 10 plus so on into 1 plus x to the 7 plus x to the 14 plus so on, and the product continues. So this boxed one corresponds to 1 by 1 minus x, right? These closed forms, we have already seen them. So whenever you get a generating function which can be written as a closed form, we do it for convenience sake, right? In the earlier video where we saw the generating function for PD of x, we had seen that it is 1 plus x into 1 plus x square into 1 plus x cube, so on. There is no more simplified version of it, or there is no closed form, and hence we left it like that. But here we see that these generating functions have closed forms, and hence we write them. And this has the closed form 1 by 1 minus x cube. This has the closed form 1 by 1 minus x to the 5, and this has the closed form 1 by 1 minus x to the 7, and so on. The further terms would be 1 minus x to the 1 by 1 minus x to the 9, 1 by 1 minus x to the 11, and so on, right? What do you observe? This in general can be written as the product of 1 by 1 minus x to the I, where I is all of your odd terms, 1, 3, 5, 7, and so on. So this is the generating function for PO of x, that is odd partitions of x. This is the generating function. Keep this in mind. You might want to watch this video again. And also again browse through the video of PD of x. We'll refer to these generating functions in the next or future videos.